All right, so now we're doing a problem called Sherlock in squares. So we want to find there are three square integers in the range. Huh? Oh, it needs to be in the range. Okay. Okay, so the first instinct is loop through every single number from A to B, check if it's a square. So do square root. Okay, yeah, the logic would be if the floor of the square root function for that number equals the ceiling of the square root, it must be an integer because floor and ceiling will bring it to the closest integer, but if it's an integer, that's not needed at all. Meaning if the floor and the ceiling are equal, which those are the rounding functions, then the number must be a square integer. But let's look at the constraints. It says A must be greater than 1 or equal to 1, and B must be less than 10 to the 9. So if we had to loop through 10 to the 9 is 1 billion. So meaning the highest test case would have to loop through every number from like 1 to billion. So that is not going to work. So the second thing in the much better way is to find the biggest square that is smaller than B. Yeah, the biggest square. And then the smallest square that is bigger than A. So I don't know how to do a ceiling and floor function, so Python mass ceiling function. And then floor should be the exact same syntax. Okay, so it's just mass.ceil. That was a lot more easy than I thought. So, oh, max, okay. Max square equals mass.ceiling of mass dot square root of B. Oh, right, unused variable. Actually, no, that's not right. It should be max.floor. Max.ceiling would be to find the smallest, yeah, the smallest square bigger than a number. So we'd take the square root of, we're going to take the square root of A, and then we're going to round up, because that'll give us the biggest square integer that's bigger than A. So we're going to do mass.ceiling here, and then mass.floor square B. Okay, this looks right. And then I think we can let's just try returning this, and then let's see if there's like an integer mismatch. Because if there is, that's going to be really easy to fix. Okay, let's run it. Hmm? B is the bigger number, yeah. Expected output 2, 1724. Yeah, because if you square root it, oh, +1. Okay, so it was an integer mismatch. We just gotta do +1. Okay, both test cases pass. Good, good. So it was just an integer mismatch. Boom. Okay, that's it. Nice. So the main logic for this problem is instead of looping through every item, just take the square root of the top of the range and then round down, which will give you the biggest square integer that's below the range, like below the top of the range, and then take the ceiling of the square root of the lower end of the range, because that'll give you the smallest square root that's bigger than the bottom of the range. I don't know why you imported random. Maybe this is just like a generic thing for every problem. Probably.